Hello and welcome. Today I will talk about stellar formation, evolution, and more. So let's start by seeing how the stars form. The whole process starts in molecular clouds known as stellar nebula. The star starts to form when the cloud starts to collapse under their own gravitational pull. The collapsed material starts to heat up and forming a core. The core is known as a protostar and it further attracts dust and gases. However, not all of the material will end up as a part of the star. So dust will become planets, asteroids, comets, or remain as dust. A star is formed when it is hot enough for nuclear reactions to start. For example, a star such as our Sun would need 50 million years to develop from the cloud to its adulthood. After the formation, if the star has a mass such as our Sun, then it will become an average star, then red giant, planetary nebula, and finally it becomes a white dwarf. If the mass is bigger or big enough, then it will become a massive star, then super red giant, supernova, and finally it will become a neutron star or a black hole. So there's many types of stars, however, there are main types, which are main sequence stars, red giants, and white dwarfs. Main sequence stars are the most common type of stars in our universe. It's about 90%. A typical member is our Sun. However, and their luminosity increases as their mass increases. Red giants, large and cool stars with a reddish appearance. The mass of a red giant can be as much as 1,000 times the mass of our Sun, and they are huge. However, this causes them to have a low density but high luminosity. White dwarfs are common stars but hard to detect due to their faintness. Formed when a star collapsing under its own gravitation stabilizes as a result of electron degeneracy pressure. This causes the star to be very dense, however its mass can be compared to the mass of the Sun, so the volume can be also compared to the of Earth. So it's basically uh, Sun but it's big as Earth. Uh, there is classification for stars depending on their temperature and color, and there is an easy way how to remember it, and it's by remembering the sentence, "Oh, be a fine girl, kiss me." Nuclear fusion. That's the main key for stars. That's how they are alive and how they survive. So imagine stars as gigantic nuclear reactors, and in the center of each star is an atomic reaction, which keeps it alive. What happens in the center? An atomic collision occurs, which takes apart atoms. The collision changes the atomic structure of atoms, causing them to release a huge amount of energy, which makes stars hot and bright and keeps them alive. Nuclei combine with another, creating a different element, and that releases a lot of energy, and this is where the equation E equals mc squared is applied, and that is conversion of energy into mass. Mostly hydrogen is converted into helium inside the nuclear reaction, and this whole process is called nucleosynthesis. So low mass stars convert often hydrogen into helium. Medium stars, for example our Sun, at their old age, when their hydrogen fuel runs out, they start converting helium into oxygen and carbon. High mass stars, after their hydrogen fuel runs out, they start converting helium into oxygen and carbon. Carbon and oxygen into neon, sodium, magnesium, sulfur, and silicon. After these elements, which I mentioned just now, are fused into calcium, iron, nickel, chromium, copper, and more. And then these elements are after sent into space because the star explodes, and these elements are needed for the basic life formation. And overall, the fusion balances the gravitational force so the star does not collapse under its own gravitational pressure. So what happens when the star dies? Everything has an end, even stars, and we can estimate stars' lifespan. For example, our sun has an estimated lifespan of 10 billion years. As a star starts dying, it starts to fuse heavier elements as its cores contract. For example, helium into carbon. As the star expands, it will fuse elements until it reaches iron, which it cannot fuse. The fusion starts to turn off. Then the star will start to die and will turn into something else depending on its mass. However, I have talked about that at the beginning, so you can just go back. And that's the life of a star. Even though their life is longer than ours, significantly, then even they end. Okay, thank you for watching. I'm sorry for not including many details. However, if it would be a really long video and it would get quickly boring. If I would include the black hole topic here and more details, then we could be here for days, maybe weeks. So that will be for another project or video because we actually know so little about the universe and we have to explore more. Thank you and goodbye.